So our goal for today's lesson is to learn how to decide if triangles are congruent. What does the word congruent mean? It's been a whole Thanksgiving break, so let's see if we remember. What does congruent mean? Equal. That means every single part of the triangle is equal. That's what we're proving today. So when we were talking about congruent line segments back in August, we talked about a line segment that was the same length. When we talk about congruent angles, we're talking about angles that are the same degree. When we're talking about triangles being congruent, we are talking about every single part of a triangle being the same. Every angle has a corresponding congruent angle. Every side has a corresponding congruent side. Now, all of this is summarized into an acronym that we're going to use called CPCTC. Whoo, tough. Y'all say CPCTC. If you're wanting to just read it, it's up here at the top of your little notes. CPCTC. It stands for corresponding parts of congruent triangles are congruent. Meaning, we need to know what is on the same part or same side as all of the things that are on the other triangle. For instance, if we look at the inside of that top part that says CPCTC, I'm going to tongue tie myself over that all day. When we are given congruent polygons or triangles, so this is going to apply for when we start studying larger shapes, corresponding sides are congruent and corresponding angles are congruent. Now, when we used in our study of parallel and perpendicular lines, when we used the word corresponding, we were talking about angles in the same spot. We are still talking about that. So if we look at our two triangles here, the top of this says that triangle ABC is congruent to triangle DEF. The order in which they write those letters is so important. What's the first letter that they gave you here? A. What's the first letter they gave you here? Those are going to be congruent to each other. So we would say angle A is congruent to angle D because they told us those in the same letter. In which case, how many arc marks can I give to angle D? 3, because angle A has 3 arc marks. Angle D can have 1, 2, 3 arc marks. What angle is congruent to angle B? E, for multiple reasons. Number 1, they're in the same location on these triangles. They will have the same arc marks. And because they are in the same location in the letters, telling me they're congruent. They're both in the middle. Which means angle C is congruent to which angle? F. Again, it would have the same number of arc marks, meaning that they are congruent. They're corresponding, they're in the same location. Now that's all of the angles being congruent. Don't forget that since it's a congruent triangle, all of the sides are congruent. So if BC has 1 tick mark, which side on this triangle would I be able to put 1 tick mark? EF. So we're saying that BC is congruent to EF. Those are in the same location. They're in between the angle with 1 tick mark and 2 tick marks, so they have 1 tick mark. They're congruent. They're the same length. What would be the same length as AB? DE. Notice that we put them in that particular order. I know that segment DE and ED are the same, but we're going to list them in the correct order. If I start at the top with A and go down to B, I start at the top with D and go down to E. And last but not least, what is congruent to AC? DF. Ooh, I forgot all of my tick marks. So we'll put 2 tick marks on DE and 3 tick marks on DF to show that those sides are congruent to each other. That's the beauty of the tick and the arc marks, is because now we can see these triangles that we were told were congruent now actually are congruent. That's corresponding parts of congruent triangles being congruent. So what I need for you to do now is I actually need you to go to your computer and open up the Desmos activity that has appeared for you today under today's class topic. We're going to do some of these slides together to make sure we understand all this corresponding stuff before I let you practice on your own. So everybody go ahead and log in. I have you paste with me, so we're going to all do this slide together. So I'll give you a second to log in, and we'll make sure we can do the first few slides of this document, of these slide decks, so that you can practice along with me for CPTC. Nope, wrong letters again. CPCTC. Whew. So we just did some practice on corresponding parts of triangles being congruent, but we have other ways to prove that triangles are congruent. These are going to be the reasons that we use in proofs to talk about different angles. The first one is called side, side, side. So in a side, side, side triangle, we are saying that we have indicated by the picture, or perhaps in a word blurb, that three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if you have a picture that is marked like this, where both triangles have a side with one tick mark, two tick marks, and three tick marks, indicating that they're congruent to each other, we can say that these triangles are congruent by side, side, side. That's how we're able to prove that they're congruent. Side, side, side. If all the sides are marked correctly, then the triangles are congruent. The next way to prove congruence is a side angle side theorem. The side angle side theorem is exactly how it sounds. If two sides and the included angle, so like literally you would see a side, an angle in between them, and another side, if those are congruent across triangles, it's enough to prove that the triangles are congruent. So notice, we have a side, an angle, and a side. So on the other triangle, all we need is a side, an angle, and a side to prove that those two triangles are congruent. Side, angle, side. I'm going to run up here to the front of the classroom. This is a disadvantage being stuck to my charger. But this is, I need you to say the things out loud to yourself when you're doing this. If you pointed out what we have a side, then an angle, then a side. That's how we know we're using that theorem. Here we had side, side, side. So we use the side, side, side theorem. Here we have a side, an angle, and a side in that order. The next theorem, the next way to prove that two triangles are congruent is with angle, side, angle, ASA. In angle, side, angle, it's kind of the opposite of what we just did. This time it's two angles and the side in between them. If those are marked as congruent, then the triangles are congruent. So we see we have an angle, a side, and a different angle. If another triangle is marked the same, angle, side, angle, then we know that those two triangles are congruent. That's what we need to prove it. So sandwiched in between two angles that are congruent is a side length that is congruent. Another one is called angle, angle, side. And again, they're named really helpfully because we're looking for an angle, and then a side not included in it. So we're looking for two angles and then a non-included side. If we can find that in two triangles, we can say that they're congruent. Notice we would have angle, angle, side. So if we see on another triangle that we have a congruent angle, and a congruent side, that is enough to prove that those two triangles are congruent. Last but not least, we have one more triangle theorem that will help us out here. It's called the hypotenuse leg theorem. This is specifically, this is specifically for right triangles. Now I know they're specifically for right triangles. Take the pass with you, please. Alani, take the pass. Thank you. Because right triangles are the only kind of triangles with hypotenuses. That's the long side diagonal from the right triangle. The hypotenuse leg theorem says that if the hypotenuse, which is again across from the right angle, and a leg of a right triangle, so one of the two other sides, if those are congruent, then the two triangles are congruent. So again, my hypotenuse, which is the long side of a right triangle, and one of the legs, if they're congruent, in a right triangle specifically, that is enough to say that those two triangles are congruent. Now, this theorem does not work if that is not a right angle. It only works if that is a right triangle. Okay, now we're going to do a little bit more of the Desmos together because we need to make sure we understand these different theorems. So I'm going to switch you over to a card sort. And that card sort is going to have you organize some sets of triangles by their congruence theorem. Let's take a few minutes and see if we can get this card sort taken care of. This secondary page of notes for today goes along with your foldable, and it talks about giving you a little bit more information about proving, so you actually proving these triangles congruent, which is our goal. Now, our goal for proving triangles congruent is to use one of the theorems from our foldable. That's how we will prove triangles are congruent. However, there's a little bit of hidden information in different images. So let's look at this hidden information cheat sheet because this is going to be helpful if you're like, I see side, side, I don't know what. Maybe you have some hidden information. The first piece of hidden information is talking way back about midpoints. Midpoints is the middle of some segments, so it results in two segments being congruent. If we know that A is the midpoint of EB, then it's telling me that immediately BA is congruent to EA. That's because this is the midpoint. So if it tells you it's the midpoint, it's actually telling you two sides are congruent because they're the same. If, let's say, instead of midpoint, they tell you that something is an angle bisector. Angle bisector is back from Unit 1. This is what we learned in like August. It results in a pair of congruent angles. So if we're saying if this line AD bisects the angle BAR, what it's really telling me is that this angle here is congruent to this angle here. They would be the same angle. BAD is congruent to RAD because it's split exactly in half, kind of like the midpoint. Angle bisector is the midpoint of an angle, essentially. Sorry. Some more hidden information is a reflexive property. Do you see in this triangle that there is actually a shared side? We have the triangle BAD, and we have the triangle DAC. But they share a common side, this side here in the middle. Well, that side here in the middle, it's going to be congruent for both triangles because they're literally the same side. So AD is congruent to AD, which seems like a duh. That's why we have this reflexive property. We learned about it way back when, and most everybody was like, that's a useless property. I mean, yes, until you see it in this picture. That each, since they share the same side or angle, it's the same. Another piece of hidden information is all about perpendicular lines. Now, most people could tell me this at the door, that perpendicular lines form a pair of congruent right angles. So if you know that AB is perpendicular to CD, sorry, that's this angle, sorry, line, congruent to this line, then we know immediately that we have a right angle here and a right angle here. That's due to the definition of perpendicular lines. They form a right angle on both sides. Couple more hidden information. The vertical angles theorem says that if two angles are vertical, meaning across from each other, like this angle and this angle, then they are congruent. So we could give them the same tick marks. Vertical angles are congruent. They may not mark them for you, but you need to remember always that vertical angles are congruent. Last piece of hidden information is about our alternate interior angles. Now this is from our super colorful document when it came to parallel lines. If AB is parallel to DC, so we have the parallel markings on them, then we have two pairs of congruent angles. We can say that DAC is congruent to ACB, and we can say that BAC is congruent to DCA. I guess I should do 3. So those alternate interior angles on either side of that transversal are going to be congruent. We learned this when we learned about parallel and perpendicular lines, but it also applies in shapes, specifically quadrilaterals that have a transversal across them. Now we're actually going to work on proving in a formal proof these sort of triangles next time. So I'm not going to utilize every single part of this document, but don't lose this document because it's going to be really, really helpful next class when we actually start writing proofs. What we are going to do to make sure we understand the different theorems from today on your foldable is a cut and paste activity. This cut and paste activity is going to be done by your group, so not individually. When your group finishes the cut and paste activity, you will finish your Desmos slides and be hopefully done with your homework for today. Let me pass that out, and then we will walk around and answer questions about these theorems as we go.